Hey guys, welcome back to part 2. Okay, just as a quick recap, talking about the blade point, and I think it's something that deserves a little bit more talking about. And simply put, is a lot of people talk about the tip on a Tanto blade, and really I just want to stress that it's going to depend. Something like this, you know, a point is going to be a point, but this is what I would consider a very broad point. You see how it flares out very rapidly after it reaches from the end back to the standard blade stock. It happens very quickly, okay, as opposed to something like on the Striker, you know, the amount of blade space before the point reconverges back to the stock blade width is going to be different. Okay, this is a very needle sharp point. It's a very slim point. Same thing on like the Emerson. Okay, whereas on the Strider design, even on the flat ground, it's going to be a much thicker, broader point. Okay, and we'll get into sort of where that plays into the functionality in a little bit. One other consideration that you should definitely take a look at, and it not only applies to Tanto blades, but other type of blades, you know, any type of knife, and that's really the quickness, or how rapid the edge converges back to or goes back to its original stock width. Okay, that's definitely going to be a consideration. On a Tanto or any straight edge knife, all along the cutting surface, the amount of material before it goes back to its grind, so as it goes along the grind, is going to be constant. It's going to be the same throughout this entire area. On a curved blade, depending upon where you are, right, the thickness is going to be different. Thickness, I mean basically from the edge to back to its stock thickness. On a curved surface, that's going to vary for each point along there. Whereas a straight edge, it's very easy to see that as you go back towards your stock blade length or blade width, you know, it's uniform. Okay? So basically your structural capability as you press down on the knife is going to be the same along the entire surface, as opposed to something like this where it's going to be a little bit weaker. There's just simply less material on different parts of the edge, between the edge and its original stock length. And especially for a blade such as this, where the stock thickness actually tapers down as you near the point, you know, even on something like this as well, it's going to vary. There's simply less steel as the blade narrows down, okay, as you go along the edge. It's just simple mechanics, simple physics, the way that is. So that's one consideration. And where am I going with this? Okay, where I'm going with it is the belief, the mystique that Tantos tend to be better piercing or stronger knives in the piercing type action, or just in general. And this is going to vary again from knife to knife. And sort of the way I'm going to try and demonstrate it is, let's say this is the material we're piercing into, okay? And just for quick intro on piercing, there's a lot of factors that are going to go into a pierce. Obviously, it's the amount of material that you are trying to force into the object, and obviously the geometry of that is going to vary. A slim point is going to be obviously better physically, less friction, less material displacing your object as it goes in. However, the other consideration with that is as you have less material here, and let's not get into steel strength or hardening or anything like that. Let's just talk same material, for example. As you go in a perfect world, you are going to be applying one type of force. However, there are going to be a lot of forces going in as you do the pierce. There will be upward and downward force, as well as lateral movement if you or the object moves as well. As you go into the object, that force is going to be applied to the blade, and if you get enough torquing force, right, it could easily snap the blade if it's more load than the metal can take. Okay, so obviously with a thinner blade stock, the amount of force necessary to break or snap the blade in a torquing movement is going to be much less than in a thicker blade. So there are trade-offs. Yes, you might go in easier to the material, but depending upon the material and the resistance, you know, a thicker blade might be better. So, and also, okay, so let's take a look at that. And let's just say this is the material going in, pretend it's a thick object and we actually have a weighted view into it. So what I'm trying to show is if we pierce into the object, let's say that far, right, with the Tanto blade, I now have been able to put in this much steel from here to there into the object in a very small amount of space. Whereas with a conventional blade, curved blade, something like this, for the same amount of distance, look at how much less blade material is going to be inside the object. Okay? So if now lateral forces or torquing forces are applied, it doesn't take a genius to look and see how much less it's going to take to snap a blade like this as opposed to a blade like this, right? Just the amount of material in there and the amount of material and leverage being applied to it on the outside. You could just see, okay? I don't want to get too deep into that discussion, but just along those lines. The next thing to take a look at in the piercing type maneuver, and this applies not only to Tantos, but to any type of knife as well, is the geometry of the blade, okay? So, what am I talking about there? Basically, it's the angle as the blade enters an object that it's going to be traveling. And something like this, right, which is a very angled type knife, right, as it travels into an object, it's not only going to be traveling inwards, but down as well. You can see that. So not only are you piercing into the object, but you're traversing along the object as well. So, this is both a good thing and a bad thing in the sense that you now are applying pressure to the main edge, but by the same token, you're also applying forces to keep the blade level. It's just basically a cross force. Whereas a type of knife like this, for example, where you have less downward action, you're going to be less friction and it might go in. And really, this isn't, like I said, specific to Tantos. It's just a consideration that you should look at when you're considering how you're going to apply a type of knife. The geometry and the angle that the blade is going to basically enter and the forces acting upon it are going to be different for every type of knife and are going to affect it differently. Long story short, what I'm trying to get at is it depends. A Tanto may not necessarily be a better, stronger piercing type knife, but then again, it could be, depending upon the situation and how it's employed. So, it's just one of those considerations. Okay, let's see. Some other things, and really, this is common sense here, and it doesn't take a genius to figure this out, but with a straight edge versus a curved edge, for the same amount of distance, you're going to be getting more cutting edge on a curved surface than you will with a straight, so that's going to affect it. The dynamics of a straight edge versus a curved edge in a cutting type maneuver are going to be different as you go through it, okay? And this sort of gets into preferences and sort of what you like and why I like Tantos or whatever. But I actually like working with a straight edge. If you haven't experienced a Tanto, get yourself a hold of a box cutter or any type of straight edge knife, and you will see, depending upon how you apply the knife, the cutting angle is always going to be the same and predictable. It's like cutting with a straight line, okay? You know exactly where the blade's going to be. It's not, you don't have to adjust yourself every time. I don't need to know how much sweep is going to be there, and while I could imagine how it's going to cut through an object, I know with the straight edge where that blade is exactly going to be. So that's one of those things I like about the Tanto blades. The other thing, and one of the reasons I like them so much, is because it gives you options, okay? Because you have both the primary point and the secondary point, and those of you who have used Tantos in the past know that a lot of the cutting activity is going to be centered around the secondary point. As you pierce into an object or begin your cut downwards, you'll notice, and again, the finger is not the best way to do it, but when you're using the second point, you are actually cutting into the object with the leading edge as well as the main edge. So the cutting is happening both before and after the point. For working with the main point, it's the same as in a regular knife. All the cutting after the point is entered is going to be behind the point. So with the secondary point, using that, you actually have two options. You're cutting in both directions. It's kind of nice. And again, the obvious, you have the option of using the leading edge or the main edge for a cut. So that's one thing. And just in general, I don't know, it really comes down to preference and what you like using and what you get used to. You're obviously limited with a straight edge in some sense that you can't really approach, depending upon the angle, like you could with a normal blade. But by the same token, you do have the leading edge or other ways to manipulate the knife. So, long story short, I just wanted to try and get across to you guys some of the differences and some of the across what we've referred to as a Tanto blade. There's lots to consider, just like with any type of knife, and there's no one way to define a Tanto. They're all going to be different. So just take a look at it, look at the different things, see what works for you, and well, enjoy. So I hope that was a little informative, a little entertaining. Sorry for the length, but as usual, questions, comments, please post them and I'll get back to you as soon as I can, okay? Thanks, guys. Have a good one. Bye-bye.